Now we are going to start with the 17th group. So if we talk about the name of the 17th group, they all members are called as halogens actually. The reason behind that is they are salt producer, that means they are salt forming actually. So what are the members of group 17? It is fluorine, chlorine, bromine, iodine and asterin. And as far as the symbols are concerned, fluorine is F, Cl is chlorine, Br is for bromine, I is for iodine and A is for asterin. So if we look for their the atomic numbers, fluorine is 9, chlorine is 17, bromine is 35, iodine is 53 and 85 is astenin. So we are going to start with the properties. So first property we are looking for is the electronic configuration, and it is particularly the general one is Ns2Np5. So if we write the configuration for them, then fluorine is 2s2 2p5, chlorine 3s2 3p5, bromine 4s2 4p5, iodine 5s2 5p5 and asterin 6s2 6p5. And you know that it is the 17th group actually, that means it is the last second group and it is the smallest group of all if we compare with the other groups. So the elements here are most electronegative, they are smallest of all, and even they possess the high ionization energy, and so they are quite reactive also because they have the high electron gain enthalpy. So therefore they exist in nature in a combined form. So what is the form of fluorine? It exists as fluorspar and cryolite. The chlorine exists as rock salt and NaCl, bromine exists as a constituent of carnallite, that is KBr, iodine exists in seaweeds, astenin, we are not aware of the much chemistry about the astenin because it is radioactive, that means it is difficult to handle. So starting with the physical properties now, the first property is atomic size. As you all know that atomic size is the distance from the center of the nucleus to the outermost shell. So if we compare its size with 16th group, so obviously they are smaller, because as you can see the configuration here Ns2Np4 and in this it is Np5. So due to increased electron, nuclear charge actually increase and size somehow decrease. Right, but if we talk of the group, so as we move down the group, every time a new shell is adding. Here the last shell is second, here the third, fourth, fifth and sixth. So that means every time a new shell is being added, due to which there is pronounced screening effect. Therefore, along group size increases due to increase in the number of shell and decrease in the nuclear charge and increase in the screening effect. So the second property is the ionization energy. What is ionization energy? Suppose this is my electron in the valence shell and I need to remove it. We know that we need to supply it with certain energy, and that is called as ionization energy. So if we talk of the ionization energy, if we compare it with the 16th and 17th group, because it is smaller, so that means ionization energy is higher. Right, and as we move down the size is increasing, so obviously ionization energy is decreasing, that means the nuclear charge is less, so therefore the electrons in the valence shell is experiencing somehow less pull from the nucleus, therefore ionization energy decrease. Next is the electronegativity. Electronegativity depends upon the nuclear charge, and nuclear charge governs the size. So as you know that it is smallest of all, being smallest, they will possess the highest nuclear charge and they will be highly electronegative. They will be highly. So if we talk of this group, fluorine is smallest of all. So that means it is going to possess the highest nuclear charge and therefore it will be highest, or you can say most electronegative element of the periodic table. Next is the electron gain enthalpy. Electron gain enthalpy is that when you need to add an electron, if we add an electron, the energy is released from an atom, that is electron gain enthalpy. So that means here the electron gain enthalpy is in negative. So more energy released means more negative electron gain enthalpy, more it has the attraction for the incoming electron. So as we have seen that as they are nearer to the noble gas configuration, as you have seen they have 7 electrons in the valence shell. So they need only 1 electron from outside, and after taking 1 electron they will attain a noble gas configuration. So they are actually having an attraction for an electron, so therefore their electron gain enthalpy is most negative in the periodic table. But as we move down, the electron gain enthalpy is becoming less negative. The reason being the size is increasing, therefore nuclear charge is decreasing, and something electron gain enthalpy is also decreasing. But if we compare the electron gain enthalpy for fluorine and chlorine, it is more negative for the chlorine and for fluorine it is less negative. The reason being, fluorine is smallest of all, so the incoming electron will suffer repulsions. So therefore, it is not in a position to accept the electron, or means it is not accepting an electron because the repulsion in it will particularly increase. So therefore, if we compare fluorine and chlorine, so chlorine is comparatively good enough in size, and the repulsions do not increase, and also it has the affinity for the incoming electron. So that means out of fluorine and chlorine, which is going to possess the highest, more negative electron gain enthalpy, it will be chlorine, because fluorine will show a certain kind of a repulsion due to the small size. Next we have is the nature of bond. So with metals, when they combine, they form an ionic bond because they need an electron, and but if they combine with non-metal, so they are linked by covalent bond. Now talking about the color, they are actually colored. Like if we talk about fluorine, chlorine, bromine, iodine, they are actually colored. The reason being, when you supply it with energy, their electrons in the vapor state particularly, they get excited to the higher energy level. Suppose this is the ground state. They get excited to the higher energy level, remain there for certain time, and when they return, they just emit the energy which falls in the visible region. But as they are smaller in size, so that means the energy which we supply from outside in order to cause the excitation is quite high. And if we compare all of them, so iodine will take less energy to show the excitation, and fluorine will show the maximum energy because its size is too small. So that means nuclear charge is too high, and you need to supply it with more energy if you need to cause an excitation, right? But still they are colored. If we talk of melting and boiling point, so you know that like if we talk about melting and boiling point, they are comparatively having the lower ones, they have the low melting and boiling point because there exists a weak force. But when we move down the group, the melting and boiling point is gradually increasing because there exists a van der Waals force between them, and due to which we know that when the size increase, obviously the van der Waals force also increase. Therefore, we get to see that fluorine and chlorine are actually gases, bromine is a liquid, and iodine is a solid. The reason behind, as we are moving, van der Waals force is increasing with the increase in the size. Therefore, you can see that there is a change in the melting and boiling point, and though there is a change in the melting and boiling point, it indicates that fluorine and chlorine are particularly gases, bromine becomes a liquid, and iodine is a typical solid. So these are about the few properties of the group 17. Now we are going to start with the chemical properties. There we will take for an oxidation state also, and then we will start with the reactions with the particular elements or the air and all. We will take that. Just look at them.